Hello guys, welcome to Ramta Solutions and welcome to your grade 11 electric circuits. In today's video, we're looking at power and energy. The scope of this video goes in this way. We're going to revise what we have learned so far. That is what we have learned in grade 10 and what we have learned in grade 11 so far in the opening chapter or in the opening units of electric circuits grade 11. And we proceed to defining power and energy. After that, we're going to look at energy cost, how we calculate energy costs. We then conclude this video with worked examples. I think there might be about two or three videos, two or three worked examples. Okay, so without any waste of time, let's get into it. So let's begin with revision. Now, in our revision, let's remind ourselves, I am not going to look at the definitions as yet, because in the previous video, we looked at that, right? In the previous video, we looked at that. But for resistance, so far, we have been saying if we want to find resistance, which is symbolized by letter R, we can say the formula we use for resistance is basically R equals V over I. Pay attention to that. This also gives us Ohm's law. Okay. And we also have voltage or potential difference. Let me call it potential difference. We also have potential difference. So our potential difference, which is symbolized by letter V, we use the formula V equals W over Q. And then we have current, which we symbolize with letter I, right? Which we symbolize with letter I as the formula I equals Q over T, right? It is the formula I equals Q over T, right? Because we also mentioned, or we spoke of Ohm's law in our introductory video of grade 11 electric circuits. We spoke of Ohm's law, which says that the potential difference across a conductor is directly proportional to current, provided temperature is constant, right? Provided temperature is constant, right? So this was giving us the impression that we can say K is equal to current over V, where this K is a constant. Perhaps let me just call it a constant and not say K. So a constant is equal to I over V. All right? These are all the things we have said so far. All right? These are all the things we have said so far. For resistance, we said it is the ratio of the potential difference to the current. For the potential difference, we said it is the work done per unit charge. For the current, we said it's the rate at which charge is moving past a fixed point in a circuit, right? We said it is the rate at which charge is moving past a fixed point in a circuit, right? This is what we said. Okay, this is what we said. Right. Now, I think I should also mention that we have what we call ohmic conductor. These are things that you may need to define. An ohmic conductor, we can call it a conductor or resistor. A conductor that obeys, let me call it a conductor that obeys Ohm's law at constant temperature. Okay. A conductor that obeys Ohm's law at constant temperature. Okay, let's just say that at constant temperature. Okay, at constant temperature. So these are all the things that you need so far for thingy. Okay, these are all the things you need for your grade 11 electric circuits. Now, let's get to power and energy. Now, power and energy, we also have to define these. Okay, we also have to define these. Now, guys, I want you to recall that we have two definitions of power. We can say one definition, we can say power is the rate at which work is done. Okay, it is the rate at which work is done. Okay, at which work is done. Okay, power is the rate at which work is done. Okay, it is the rate at which work is done. Okay, so we symbolize power with letter P. So symbol is P. SI unit of power is watt. Okay, capital watt. So the symbol for watt is W. Okay, now from this definition, I want you to check this out. We say power, which is P, is equal to rate. Remember, when we say rate, it means you must divide by T, at which work is done, right? It is the rate at which work is done. So power is W over T. Okay, power is W over T. All right, now I need to remind you guys, remember, opening part of this video, we said potential difference is work done per unit charge. Okay, so attention, I'm saying, remember, voltage is work done per unit charge. Now this implies, what does it imply? It implies that work done is voltage times charge. Okay, hold it there. Also, remember that current is charge divided by time. Therefore, we can say, remember, we were saying power is equal to W over T. This therefore tells us that we can say W is V Q over T. What is this part representing? This part represents I. So this is V sub, sorry, VI. Why am I saying V sub I? So power is VI. Okay? Power is VI. But this can be further expanded. Okay, this can be further expanded. Remember, we said R equals V over I. This could imply V is equal to IR. Also imply that I is equal to V over R. Right? So check this out. We are saying that power is equal to R. Now I'm going to break this down. We can say V, now I'm changing current. Instead of, if I don't have current and I have potential difference and resistance, I know I can say I is equal to V over R. As you can see, here is it, V over R. V over, right? So what is this? This is V squared over R. Therefore, you can also define power as V squared over R. Now, you have current, but you don't have potential difference. If you have power, but you don't have potential, you have current, but you don't have potential difference, you can say, in place of V, you put I R. Right? You put I R. So what will this become? This will say power is now I squared times R. Right? It will mean that I squared is power is I squared R. Okay, so this equation of power has been reduced to how many forms? I think 4 forms. So we can say power is equal to W over T which could then be power. Let me do this, which could be broken down to, let me do this, which could be broken down to power equals VI, or power is equal to V squared over R, or power is equal to I squared. Okay, or power is equal to I squared R. So these are the equations of power that you will come across. Okay, these are the equations of power that you will come across. Okay, these are the equations of power that you will come across. Okay, so far we have 4 that we can use. Okay, we have 4 that you can use. Remember, guys, the beauty of you being a student is that, and I always tell my students that, listen, guys, when you are done with your grade 12, you must have proved all the formulas in your answer sheet from grade 10 to 12. You must have proved all of them, or you must have derived all of them. Okay, so now you have derived the power equations. Happy? Now let's then refer to energy. I'm gonna be using another definition of power. Okay, another definition of power. Another definition of power. Remember, guys, you said power, let me call it P. What is it? Is the rate at which energy is transferred. The rate, oh boy, the rate at which energy is transferred. Right, is the rate at which energy is transferred. Right, it is the rate at which energy is transferred. Power is the rate. When I say rate, what comes to mind? Time. Energy from grade 10. You remember in grade 10 you were dealing with mechanical energy and potential energy, kinetic energy as well, right? Energy is symbolized with the letter E. So from here we can say, oh, so if I want energy, I can therefore say energy is power times time. Remember, unit of energy, unit of what? Joules. Joules capital J. Okay, joules capital J. Okay, units of energy are joules capital J. But of course, this capital J, as you can see, it is basically, let me go to the next page. Remember we said energy is power times time. What are the units of power? What are the units of time? Seconds. So 1 joule is equal to, 1 watt times second. Okay, 1 joule is equal to 1 watt times second. Okay, this is what this is. Okay, perfect. Now let me see what I have said. Energy cost. Now we need to look at energy cost. Okay, now we need to look at energy cost. I think it's number 3. Energy cost. So, ESCOM, what does it do? So what ESCOM does, ESCOM sells electricity in kilowatts hour, isn't it? So ESCOM sells electricity, you know ESCOM. ESCOM sells electricity. If you are watching outside South Africa, ESCOM is our electricity supply company, okay? So ESCOM sells electricity in kWh. What is this? This is kilowatt hour. Okay, in kilowatt hour. Okay, in kilowatt hour. Now, remember, we said energy is equal to power times time. Now, according to this, according to this, it means now this power must be in kilowatts, and then the time must be in hours. Okay, the time must be in hours. Okay, the time must be in hours. Okay, so then you get a tariff. You get a tariff. A tariff could basically be I'm just gonna say this, whether it's in your currency or cent, it doesn't matter. So it'll be your in currency per kilowatt hour. This is what you will be getting. Okay, your tariff will be currency per kilowatt hour. Normally, if you don't want to say tariff, you can call it a price. Okay, you can call it a price. Okay, so we therefore want to come to this, guys. Electricity is sold in whatever currency per kilowatt hour. Right, so this therefore must be giving you this. Oh, so if we say it is in currency, check this out. This is currency, and then per kilowatt hour. Per kilowatt hour. Then we go down. Okay, let me say currency, and then you are kilowatt hour. Here, kilowatt hour. So what is this? This is tariff. Okay, let's say this is tariff. Oh yeah, I'm gonna call this a tariff. I'm gonna call this a tariff. I'm gonna call this a tariff. Okay, so a tariff is currency per kilowatt hour, right? A tariff, your tariff is in currency per kilowatt hour. If you want to know what your kilowatt hour is, you can use the currency that you got and your tariff, something like that. But I want to simplify this for you and say this is how it rolls. So I'm going to put it in this way. I'm going to change this now. Okay, I'm going to change this now and say, so what we are saying is this. So what we are saying is, this is your cost, and then this is your energy, and then this is your tariff. Okay? Others, instead of calling this a tariff, they call it a price. Okay, they call it a price. Okay, remember, your energy is power times time, right? This is energy. It's power times time. So in other words, your questions, you must say cost is equal to energy times tariff. You call it tariff or you call it price, it's okay. So what is this energy? Energy is power times time multiplied by your tariff. Okay, multiplied by your tariff. Okay, so now this is it. This is how you calculate the cost of your electricity usage. All right. So with that being said, we are now ready to get into worked examples. So I hope you guys understand this. So from this triangle, if they want to ask you how much does what is the price of electricity, you can say it is the cost that the usage costs and the energy that the usage uses. Okay, and that'll be your cost. That'll be your tariff for the price of your electricity. Okay, perfect. Now, item 4. This is worked examples. This is worked examples. This is worked examples. So worked examples, I'm going to begin with this one here. The first one, example 1, it says, calculate the power. Let me write this down. Calculate the power. Leave it. A 3-volt torch that has 600 coulomb passing through. Passing through in 0.5 hours. Okay, our solution, say this. We are looking for power. Cool. Voltage given is 3 volts. We are given charge is 600 coulombs. The time is given in hours. And what we know that we need to convert hour to seconds. So we will need to multiply by 3,600. Right? We will need to multiply by 3,600. Therefore, this will be, let me say this, 0.5 times 3,600 seconds. This will be half of it, 1,800 seconds. This is our time. Right? Perfect. So, we have power equals VI. This is what we're going to use, right? Power equals VI. If you like, you can say this is power equals Q over T. That's okay. We can proceed in that manner. We are good. So what is this? This is 3 times 600 over 1,800. What is this? This is 1 watt. Or you can say this. Oh, current is Q over T. What is Q? Is 600. What is time? It's 1,800. What is this? This is 1 over 3. So this is 1 over 3. 600 over 1,800 is 1 over 3. So I don't really have to round off in the middle of a calculation. So maybe let me 0.333. Okay? Let me just round it off. It's fine. 0.33. But you don't have to round off, guys, in the middle of a calculation. Okay? So this is 0.33 amperes. Okay? Now, therefore, power is voltage times current. So what is this? 3 times 0.33. Or do you get 0.33 times 3? Obviously, it's 0.99. Right? It's 0.99 watts. Of course, this is closer, or it is in fact 1 watt. Okay? It is in fact 9 watt. If you calculate it in this way or this way, you're still going to get all your marks. Okay? You're still going to get all your marks. Okay? Still going to get all your marks. Issue here that isn't getting 0.99 is because we had rounded off, and it's not advisable to round off in the middle of your calculations. But of course, follow the structure of your exam. If they are asking parts, just use the value that you calculated in the previous question to substitute it here. But if not, take this value as series and you'll get 1 watt because it's permissible. Okay? So it's 1 watt. Right. Perfect. Now, example 2. Example 2 says, let's see, a kettle. Guys, this read, I don't like reading it much because, you see, now when we come across this way, you find us saying this kettle. So yeah, this kettle is marked. This kettle is marked 240 volts is to 1,500 watts. Okay. A, calculate the resistance of the kettle. Calculate the resistance of the kettle. Calculate the resistance of the kettle. B, takes 3 minutes. Hope I wonder in which season. It takes 3 minutes to boil water. It takes 3 minutes to boil water. Calculate the amount of electrical energy transferred to the kettle. Transferred to the kettle. To the kettle. Okay. Now our solution, this kettle is marked 250 volts and 1,500 watts. Calculate the resistance. So what we know, we are given voltage and we are also given power. Now, to answer question A, we know power is equal to V squared over R. What is the power? It's 1,500. All right. And what is the voltage? It's 240. What is the resistance? It's unknown. Right? Perfect. So, going to the next page. This means R equals 240 squared over 1,500. What is our answer? Or 1,500. Yeah. So this is 38.4 ohms. All right. So the resistance of this kettle is 38.4 ohms. All right. The resistance of this kettle is 38.4 ohms. Remember those formulas that we were deriving. Now we're using them. How nice. Very nice, eh? Question B. It takes 3 minutes to boil water. Oh, time is 3 minutes. Now, time is always given in seconds. So we need to convert minutes to seconds. We will have to multiply by 60. So this is 180 seconds. Okay? Now, we're calculating the electrical energy transferred to the kettle. This is okay. So we know that power is equal to energy over time. So what is power? The power given is 1,500. What is the energy? We do not know. What is the time? 180 seconds. This implies energy is 1,500 multiplied by 180. What is our answer? See? It's equal to 270,000. So energy is equal to 270,000 joules. If you like, you can write this as 270 kilojoules. Okay, you can write this as 270 kilojoules if you like, because this is 1,000. Okay, you can write it as 270 kilojoules. Happy? Perfect. Okay, now let's get to the third example. The third example, let's see. The third example says, how much does it cost? How much does it cost to run a 900 watt microwave oven for 2.5 minutes? For 2.5 minutes, if the cost of electricity ESCOM, if the cost of electricity is 61.6 cents per kilowatt hour. So remember, I gave you this triangle in our solution data. solution. Let me remind you, I gave you this triangle. I said call this a cost, and then call this energy, and then call this tariff. All right? Now we are looking for the cost. So if you recall, we will basically say cost is energy times, right? What is this energy? This energy is power times time, of course, times tariff. Remember, if you don't want to say tariff, you can say plan, right? Okay, so let's get our energy. So energy here, energy is PT, and be careful, you must get it in kilowatt hour. So what will this be? This will be 900 watts. 900 watts has to be converted to power. Let me say this. Power is 900 watts. When we want to convert it to kilowatt, we will divide by 1,000. Okay, so we divide it by 1,000. Okay, when we divide it by 1,000, we get kilowatts. So this will be 0.9 kilowatts. Now, the time, let's go check the time. The time is in 2.5 minutes. It must be in hours. So 2.5 minutes, it must be in hours. So 2.5, to convert it to hour, we divide by 60. Okay, we divide by 60. 2.5 divided by 60. Won't be nice. I'm going to leave it as is, to be honest, because it's a very big number. So I'm going to leave it as 1 over 24. Okay, I'm going to leave it as 1 over 24 hours. Okay, or if you like, let me use a different color. If you like, this is 0.0417 hours. It's okay like that. Okay, so the tariff is in cents per kilowatt hour. It's fine. Okay, so now we are saying the cost is energy. What is this? Power times time times tariff. Right? What is the power? It's 0.9. I want to write this, guys, in this way, so to show you why. Okay, but it's fine. I don't have to. I can write it without units. The time is, allow me to call it 1 over 24 for now. And the tariff, what was it? It was 61.6 cents. It was 61.6. Okay, it was 61.6. I would explain this thing that I wanted to explain just now. So let's get our cost. Our cost is 0.9 times 1 over 24 times 61.6. Right, 61.6. What do we get? We get 2.31 cents. So the cost of electricity to run this microwave oven is 2.31 cents. Okay, it's 2.31 cents. So let me now explain the difference that sometimes you need. And by the way, if you were using this value, let's see what you are going to get. You're going to get cost equals 0.9 times 0.0417 times 61.6. You're still going to get, I guess, the very same thing, close to. All right. So let's see, 0.0417. You're going to get exactly, you're still going to get 2.31 cents. All right. You're still going to get 2.31 cents. All right. You're still going to get 2.31 cents. Isn't it? Perfect. So now, something that I want to show you guys. Dimensional homogeneity is very important. Okay. Dimensional homogeneity is very important. We're saying cost is equal to energy times tariff. Okay? In our example, we were saying this is 0.9 kilowatts multiplied by 0.0417 hours multiplied by 61.6 cents per kilowatt hour. You see this, I said per and I wrote this as a denominator. This is to show you that the kilowatt cancels with the kilowatt, the hour cancels with the hour. Hence, your answer becomes, 2.31 cent. You are only left with the C, as you can see. You are only left with the C. If this was rand per kilowatt hour, you will only be left with your rand. So make sure that your energy, you convert it to whatever units that your tariff is calculated at. Normally it's kilowatt hour. So make sure that your energy, the power is always converted to kilowatt. Okay. Make sure that for your energy, the power is converted to kilowatt. Okay. All right, guys. So we have come to the end of our session. And if you would like to get in touch with us, you can you can visit our website at Ramta Solutions.co.za. From the very same website, you will see these icons at the top on your website. You will see these icons, and you can click on any of them. Or click on this one if you want to send us an email. And of course, you're watching this video on YouTube. So I hope on YouTube you're subscribing, liking my videos, and sharing with your classmates. And then you can also follow us on Twitter. Oh, we call it X now. You can also follow us on X. You can follow us on Facebook and Instagram as well. Again, on the very same website, there is a page called the blog page. On the blog page, we have different articles we have many articles that are explaining different math and science topics. Okay, you can make use of that blog page to read on different topics. Okay, and again, there's a get a tutor page if you would like a tutor, or if you'd like to work with us. You can leave your details on that page and tell us what subject or subjects you're looking for and the grade that you're doing. Leave your contacts and we will communicate with you. And with that being said, we hope this video made a difference for you guys, and we're leaving it here. So ours ends here, and we will see you next time. And the next time we see you on grade 11 electric circuits is when we look at past papers. Okay? So, all the best, guys. Bye-bye.